They tell you that the graph of log base 10 n versus t is shown here, which means the x-axis is t, y-axis is log base 10 n, and we know the graph is a straight line graph, goes through 0 comma 2. So the initial number of bacteria means when t equals to 0, we need to find the value of n. So we know when t equals to 0, the y-intercept is 2, which means log base 10 n is 2. So n is 10 to the power of 2 and n is 100. So initially there should have been 100 bacteria in this colony. Okay, and B part, they tell you show that the equation of the model can be written in the form of n equals a b to the power of t. However, we can say the y-axis b log base 10 n is a straight line graph, which means it should be in the form of m times x-axis t plus c. Since it goes through 0 comma 2, we can simply say that c is 2. When you substitute 0 and 2, we can figure out that c is 2. Also, the graph passes through 3.6 comma 3.26, so the gradient should be 3.26 minus 2. 3.26 minus 2 divided by 3.6 minus 0, and this should be 7 over 20, in other words 0.35. So now you can write the formula log base 10 n equals to 0.35 t plus 2. So we can take the log base 10 to the other side, so it becomes n equals 10 to the power of 0.35 t plus 2. So I'm going to use the laws of indices, where when you have multiplication you add the powers. So if their powers have been added, you can separate them. 0.35 t times 10 to the power of 2, and 10 to the power of 2 is 100, so n equals to 100 times 10 to the power of 0.35 t. Now this is in the form of n equals a b to the power of t. So we need to do a small adjustment, because a is 100, but however b to the power of t means you should have n equals to 100 times 10 to the power of 0.35 whole thing power of t. Once again, application of index loss. So now what is 10 to the power of 0.35? That has to be 2.238. So I'm going to write to 3SF n equals 100 times 2.24 to the power of t. That gives me b equals to 2.24. Part C, they want b to 2 decimal places, so we just found that. Part C, hence find the rate of growth of bacteria on the surface exactly 5 hours after monitoring began, which means we got to simplify this. dn by dt should be 100 is a constant, then you can say 2.24 power of 2 times ln 2.24, because differentiation of a to the power of x is a to the power of x ln a. So this value, and when t equals to 5 hours, we can substitute and find the rate of change. dn by dt equals 100 ln 2.24 times 2.24 power of 5. So let's find this. That should be 4,531.9. So we can give the answer correct to 3SF. So dn by dt equals 4,530 bacteria per hour. So that would be the answer for part C.